time travel and the paradoxes that could break reality. Time travel has fascinated humanity for centuries, appearing in everything from ancient myths to modern movies. But could it ever become a reality? And if so, what would it mean for the universe and for us? The idea of time travel is rooted in Einstein's theory of relativity, which shows that time isn't fixed, it's flexible. Time moves more slowly for objects traveling at high speeds or near massive gravitational fields. This phenomenon, known as time dilation, has been experimentally verified. For example, astronauts on the International Space Station experience time just a tiny bit slower than people on Earth because of their speed and distance from the planet's gravity. In theory, time dilation could allow us to travel into the future. If you boarded a spaceship traveling at near light speed, time for you would slow down dramatically compared to people on Earth. You could experience just a few years on your ship, while centuries pass back home. Traveling to the past, however, is far more complicated. One theoretical method involves wormholes, which are shortcuts through space-time. If one end of a wormhole is accelerated to near light speed and then brought back, it could exist at a different point in time than the other end. In theory, you could step into one end of the wormhole and emerge in the past or future. Another possibility involves using black holes or other objects with extreme gravity to manipulate time. The intense gravitational pull near a black hole warps space-time so much that time slows down dramatically. If you could orbit close enough to a black hole without being destroyed, you might experience years passing for every hour outside the black hole's influence. But time travel comes with a host of paradoxes. The most famous is the grandfather paradox, where traveling to the past creates a contradiction. If you go back in time and prevent your grandfather from meeting your grandmother, you'd never be born. So how could you have traveled back in time in the first place? Another is the bootstrap paradox, where an object or piece of information is sent back in time, creating a loop with no clear origin. For example, imagine giving your younger self a book about physics. They grow up, write that book, and then give it back to their younger self. Who actually wrote it? Some physicists believe these paradoxes could be resolved by the many worlds interpretation, which suggests that every time a paradox occurs, a new timeline branches off. In this model, you couldn't change your own past. You'd simply create an alternate reality. Time travel may remain speculative, but it forces us to rethink the nature of reality. If we ever unlock the secrets of space-time, we might not just travel to the past or future, we might discover entirely new dimensions of existence. Will humans live on Mars by 2040? Elon Musk's vision versus reality. Colonizing Mars by 2040 sounds like something straight out of a sci-fi movie, right? But for Elon Musk, it's not just a pipe dream, it's a mission. SpaceX isn't aiming for a few flags and footprints. Musk's goal is to build a full-blown city with 1 million people. Imagine that, schools, farms, and maybe even Martian coffee shops. It sounds incredible, but how realistic is it? Let's break it down. First, let's talk technology, because no amount of ambition can overcome physics. Getting humans to Mars is already hard enough. SpaceX's Starship rocket is designed for the job, fully reusable, with the capacity to carry over 100 tons per trip. But landing humans safely on Mars is just step one. Mars is freezing cold, with temperatures dipping to -80 degrees Fahrenheit, and the planet has no breathable atmosphere. If you step outside without a suit, the radiation alone would cook you. And then there's the dust. Martian dust isn't like the stuff on your bookshelf. It's electrostatically charged, meaning it clings to everything and can damage electronics. And did I mention the dust storms? They can last for months, covering the entire planet. Scientists would need to design habitats that not only shield us from radiation and cold, but also withstand those storms. Some proposals suggest using 3D printers to build habitats out of Martian soil, but even that is still in experimental stages. Then there's the food problem. Martian soil isn't just barren, it's toxic, filled with chemicals like perchlorates that would kill plants. So, farming would require either importing massive hydroponic systems or developing tech to clean the soil. Scientists are already working on solutions. For example, NASA has been experimenting with growing crops in simulated Martian soil on Earth, and certain types of algae might thrive on Mars and help produce both oxygen and food. But scaling this up to feed a city, that's a challenge no one's cracked yet. And let's not forget about humans. The journey to Mars alone would take around 7 months, and that's just the start of the physical toll. In low gravity, astronauts lose muscle mass, bone density, and even changes to their vision due to fluid buildup in the brain. Living on Mars, with only a third of Earth's gravity, could have similar effects. And then there's the mental strain. Imagine being millions of miles away from Earth, knowing the nearest help is at least 6 months away. Psychological challenges like isolation, cabin fever, and conflict could make life on Mars, well, less than ideal. Now, let's talk money. A Mars colony won't come cheap. Musk himself has estimated that building a self-sustaining city could cost up to $10 trillion. Yes, trillion with a T. While SpaceX has made reusable rockets to slash costs, funding a Mars mission will require more than just one company. Governments, private investors, and even crowdfunding might play a role. But here's a question. If Mars is only for those who can afford it, are we just creating a new frontier for inequality? And yet, progress is undeniable. NASA is testing habitats in remote locations like the Utah desert to simulate Mars conditions. SpaceX has already conducted multiple successful Starship launches. And researchers are exploring ways to produce oxygen on Mars using its CO2-rich atmosphere. In fact, the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, was tested on the Perseverance rover and proved that converting Martian air into oxygen is possible. So, will humans live on Mars by 2040? The short answer is, maybe. The roadmap is there, but the challenges are monumental. It's not just about technology, it's about pushing the limits of what humanity can achieve, both scientifically and socially. If we do pull it off, it won't just be a new chapter for space exploration. It could be the beginning of humanity's life as a multiplanetary species. The truth about faster than light. Travel, fantasy or inevitable reality. Faster than light, FTL. Travel has always been a staple of science fiction. Warp drives, hyperspace jumps, and wormholes are the bread and butter of interstellar adventures. But is FTL travel just fantasy, or could it actually become a reality? Let's dig into the science. The biggest problem is physics. According to Einstein's theory of relativity, nothing can travel faster than the speed of light in a vacuum. It's a cosmic speed limit. Light moves at about 186,000 miles per second. And if you're trying to accelerate anything with mass to that speed, the energy required becomes infinite. Not just a lot of energy, but literally infinite. That's kind of a buzzkill. But that doesn't mean we're stuck crawling across the cosmos forever. Scientists have proposed some fascinating ways we might bypass the light speed limit without breaking physics. One of the most exciting ideas is the Alcubierre drive, a theoretical concept named after physicist Miguel Alcubierre. Instead of pushing a spacecraft faster than light, this drive would compress space in front of the ship and expand it behind, creating a sort of warp bubble that carries the spacecraft along. Technically, the ship itself wouldn't move faster than light. It's the space around it that's doing the heavy lifting. The math behind the Alcubierre drive checks out, but there's a catch. It would require an enormous amount of energy. Some estimates suggest you'd need the energy equivalent of a planet-sized mass to power it, and that's assuming we can even generate negative energy, a theoretical substance needed to create the warp bubble in the first place. Scientists are still debating whether negative energy can exist outside of quantum experiments. Then, there's the idea of wormholes, shortcuts through space-time that could theoretically connect two distant points in the universe. Imagine folding a piece of paper in half and punching a hole through it. That's essentially what a wormhole does. But again, the challenges are enormous. For one, wormholes would be incredibly unstable. Without some form of exotic matter to keep them open, they'd collapse the moment anything tries to pass through. Even if we overcome the energy and stability issues, there's another question. How do you navigate through these phenomena? Warp bubbles and wormholes aren't exactly highways with signs pointing you to Alpha Centauri. We'd need incredibly advanced navigation systems, possibly powered by AI, to map out safe routes through the cosmos. Despite these challenges, the idea of FTL travel isn't entirely out of reach. Recent experiments with quantum mechanics have shown that particles can appear to communicate faster than light. Although this doesn't allow for actual travel, it suggests there's still much we don't understand about the universe. So, is FTL travel fantasy or reality? Right now, it's firmly in the realm of science fiction, but history has a funny way of turning the impossible into the inevitable. After all, powered flight was once considered a fantasy, and now we're flying to space. If humanity's curiosity and determination continue to push the boundaries, faster-than-light travel might one day be more than a dream. What happens to the human body? During space travel is humanity's ultimate adventure, but it's also a massive challenge for the human body. Living in space, even for a short time, can affect everything from your bones to your brain. So, what actually happens to the human body when we venture into the final frontier? First, let's talk about gravity, or the lack of it. On Earth, gravity pulls on your muscles and bones constantly, keeping them strong. But in microgravity, like on the International Space Station, your body doesn't have to fight against that pull. As a result, astronauts lose muscle mass and bone density. Studies show astronauts can lose up to 1% of their bone mass per month in space. Think about that. Months or years in space could leave you with the skeleton of someone decades older. Muscles don't fare much better. Without the need to support your body weight, they start to weaken and shrink. That's why astronauts spend 2 hours a day exercising on specialized equipment like resistance machines and treadmills, just to keep their bodies functioning. But it's not just muscles and bones that take a hit. Space travel also affects your cardiovascular system. On Earth, gravity helps pull blood toward your lower body, but in space, it redistributes and pools in your upper body. This is why astronauts often look puffy-faced in photos. They're literally carrying extra fluid in their heads. This can lead to headaches, nasal congestion, and even vision problems caused by pressure on the eyes. Then there's radiation. Space is full of high-energy particles from the sun and beyond, and Earth's magnetic field usually protects us from these cosmic rays. But once you leave Earth's atmosphere, you're exposed. Over time, this radiation can increase the risk of cancer and damage to your nervous system. For astronauts on long missions, like a trip to Mars, this is a major concern. Even your brain isn't safe. Studies suggest that spending time in space can lead to cognitive changes, including slower reaction times and difficulty concentrating. It's not entirely clear why, but it could be related to changes in blood flow, stress, or the effects of prolonged isolation. Speaking of stress, mental health is another huge challenge. Imagine being stuck in a cramped spacecraft for months, millions of miles from home, with the same small group of people. Cabin fever, anxiety, and depression are real risks for astronauts. NASA and other space agencies put a lot of effort into training astronauts to handle these pressures, but it's an ongoing challenge. So, what does this mean for humanity's future in space? The good news is, scientists are working on solutions. Artificial gravity could help prevent muscle and bone loss, while shielding technology might protect against radiation. There's even research into using drugs to counteract some of the effects of microgravity. But one thing is clear. If we're serious about exploring space long-term, we'll need to figure out how to protect our bodies and minds from the unique challenges of living off Earth. Will space hotels be the new exotic vacation spot? Imagine booking a room with a view, not of the ocean, but of Earth from 200 miles above. Space hotels sound like a sci-fi fantasy, but they're closer to becoming reality than you might think. So, are space hotels the new frontier for exotic vacations? Several companies are already working on it. Orbital Assembly Corporation plans to open the world's first space hotel, called Voyager Station, by 2027. The design looks like something straight out of a movie. A massive rotating ring with luxurious suites, restaurants, and even a gym. The rotation would generate artificial gravity, so you wouldn't have to worry about floating around while sipping your space cocktail. Then there's Axiom Space, which aims to attach commercial modules to the International Space Station as early as 2025. These modules would offer both research facilities and accommodations for private tourists. Essentially, you'd be staying in a high-tech lab with one heck of a view. But let's talk about the price tag. A trip to space isn't exactly budget-friendly. In 2001, Dennis Tito became the first private space tourist, paying $20 million for a week-long stay on the ISS. Prices have come down since then, but we're still talking tens of millions of dollars. Companies like SpaceX and Blue Origin are working to lower costs with reusable rockets, but it's going to be a long time before space vacations are affordable for the average person. And even if you can afford it, space travel isn't exactly a luxury experience, at least not yet. Astronauts on the ISS live in cramped quarters, eat freeze-dried food, and deal with zero-gravity bathrooms, which are not ideal. Space hotels would need to address these challenges to create an experience that feels more like a vacation and less like survival training. But the potential is huge. Imagine looking out your hotel window and seeing Earth glowing below, or experiencing weightlessness in a dedicated recreation area. Companies could offer once-in-a-lifetime experiences like spacewalks, or even trips to the moon and back. Of course, there are risks. Space travel is still dangerous, with the possibility of launch failures, radiation exposure, and other hazards. Any company offering space tourism would need to take extraordinary measures to ensure safety. So, are space hotels the future of vacations? For now, they're a luxury reserved for the ultra-rich. But as technology advances and costs come down, who knows? In a few decades, you might be booking your next getaway in orbit. The Moon, humanity's next base camp. For decades, the Moon has been our closest neighbor and a source of fascination. But it's no longer just a target for flags and footprints. Now, it's being eyed as humanity's next big base camp. Could the Moon really become our springboard to the stars? Let's start with the why. Building a base on the Moon has some major advantages. For one, it's close. At about 240,000 miles away, the Moon is just a 3-day journey from Earth. That makes it a perfect testing ground for technologies we'll need for long-term space exploration. If something goes wrong, help isn't months away like it would be on Mars. It's just a few days. Then there's the science. The Moon's lack of atmosphere makes it an incredible spot for astronomy. Telescopes on the lunar surface wouldn't have to deal with light pollution or atmospheric distortion, meaning we could observe the universe in stunning detail. And let's not forget the Moon's south pole, where permanently shadowed craters may contain water ice. That ice could be turned into drinking water, breathable oxygen, or even rocket fuel. Speaking of rocket fuel, the Moon's lower gravity makes it a fantastic location for launching missions deeper into space. It takes far less energy to escape the Moon's gravity than Earth's, so a lunar base could act as a refueling station for missions to Mars and beyond. So, what would a moon base look like? NASA's Artemis program aims to land humans on the Moon by 2025, with plans to establish a sustainable presence by the 2030s. The Lunar Gateway, a small space station orbiting the Moon, will serve as a staging point for lunar landings and as a hub for research and exploration. On the surface, habitats would likely be built using materials from the Moon itself, like regolith, a fancy word for lunar dirt. Scientists are already testing ways to 3D print habitats using this material. But it's not just NASA getting in on the action. China has its sights set on the Moon, with plans to establish a lunar research station, by the mid-2030s. Russia and private companies like SpaceX and Blue Origin are also exploring ways to contribute to lunar exploration. Of course, building a moon base isn't without challenges. The lack of atmosphere means temperatures swing wildly, from 250 degrees Fahrenheit during the day to negative 280 degrees Fahrenheit at night. Radiation is another big problem, as the moon doesn't have a magnetic field to shield against solar and cosmic rays. Any base would need significant protection, possibly underground or covered in layers of regolith. And then there's the cost. Lunar missions are expensive, with Artemis alone projected to cost tens of billions of dollars. But the potential benefits, both scientific and strategic, could make it all worthwhile. In the long run, the moon might not just be a base camp for exploration, it could also become a hub for industry. Mining operations could extract valuable resources like helium-3, a rare isotope that could be used in future nuclear fusion reactors. And who knows? With enough investment, the moon might even become a destination for tourism. The moon is more than a stepping stone. It's a proving ground for humanity's ambitions in space. If we can make life sustainable there, it'll be a giant leap toward making life multiplanetary. Mining asteroids, the billionaire gold rush of the future. Imagine an asteroid the size of a city hurtling through space, packed with metals worth trillions of dollars. Sound like a sci-fi heist? It's actually a real possibility, and some of the world's biggest companies are racing to make it happen. But could mining asteroids really revolutionize our economy? Asteroids are like cosmic treasure chests. Many of them are rich in metals like gold, platinum, nickel, and iron. For example, the asteroid 16 Psyche is estimated to contain $10,000 quadrillion worth of precious metals, enough to crash Earth's entire economy if we ever brought it all back. But it's not just about bling. Rare earth elements, which are essential for making electronics like smartphones and batteries, could also be found in abundance on asteroids. With demand for these materials skyrocketing, asteroid mining could help ease supply chain issues and reduce the environmental impact of mining on Earth. So how do we actually mine an asteroid? The concept is still in its infancy, but there are a few ideas. One involves sending robotic spacecraft to land on an asteroid, extract the materials, and return them to Earth. Another idea is to process the materials in space and only bring back what's needed. Companies like Planetary Resources and Deep Space Industries have been exploring asteroid mining for years, though both have faced funding challenges. But as launch costs continue to drop, thanks to reusable rockets like SpaceX's Falcon 9, asteroid mining is starting to look more feasible. NASA is also getting involved. In 2021, the agency launched the Lucy mission to study Trojan asteroids near Jupiter, and it's planning a mission to 16 Psyche in the near future. While these missions are focused on research, they could lay the groundwork for future mining operations. Of course, there are huge challenges. First, there's the technology. Landing on an asteroid isn't easy. They're small, they spin, and they have almost no gravity. Then there's the legal question. Who owns the resources in space? Current treaties, like the Outer Space Treaty of 1967, say no one can claim celestial bodies. But that hasn't stopped countries like the US and Luxembourg from passing laws to allow companies to own what they mine. Then there's the cost. Even with reusable rockets, mining an asteroid and returning materials to Earth would be insanely expensive. It might only make sense to mine materials for use in space. For example, using asteroid metals to build spacecraft or habitats in orbit. But if the challenges can be overcome, the rewards could be astronomical. Asteroid mining has the potential to unlock resources that could fuel not just our economy, but our future in space. Imagine a future where we're building massive space stations, refueling missions to Mars, and creating technologies we can't even imagine, all powered by materials from asteroids. So, is asteroid mining the gold rush of the future? It's too early to tell. But one thing's for sure, the race is on, and the stakes couldn't be higher. Terraforming Venus. Can we make hell a paradise? When we think about colonizing another planet, Mars usually gets all the attention. But what about Venus? Sure, it's a hellish world where temperatures can melt lead, and the atmosphere is packed with carbon dioxide and sulfuric acid. But some scientists believe we might be able to transform it into a paradise. Could terraforming Venus actually be possible? First, let's address the obvious. Venus is hostile. Its surface temperature is around 900 degrees Fahrenheit, hot enough to fry pretty much anything. The atmospheric pressure is 92 times that of Earth's, meaning it would crush you like a tin can. And let's not forget the clouds of sulfuric acid that constantly rain down. It's not exactly a weekend getaway. So, how do you take a planet like Venus and make it livable? The answer lies in terraforming, essentially engineering an entire planet to make it more Earth-like. The biggest challenge on Venus is cooling it down and reducing the carbon dioxide in its atmosphere, which makes up 96% of the air. One proposal involves using giant mirrors in space to reflect sunlight away from the planet. Over time, this could cool Venus enough to stabilize the surface. Another idea is to introduce massive amounts of hydrogen into Venus's atmosphere to react with the carbon dioxide and form water. This process could theoretically create oceans. The problem? You'd need an unimaginable amount of hydrogen, likely harvested from gas giants like Jupiter. Some scientists suggest we focus on colonizing Venus's atmosphere instead of its surface. At an altitude of about 30 miles, the pressure and temperature are surprisingly Earth-like, and the thick clouds could provide natural protection from radiation. Floating cities in Venus's skies, powered by solar energy, could be a stepping stone toward more ambitious terraforming efforts. Of course, the challenges of terraforming Venus are enormous. The sheer scale of the engineering required is hard to comprehend. We're talking about projects that would take hundreds or even thousands of years to complete. And then there's the ethical question. Should we even try to terraform another planet? Venus is a natural world with its own history and geology. Do we have the right to change it so drastically? But there are reasons to consider it. Venus is closer to Earth than Mars, and its gravity is similar to ours, making it easier for humans to adapt. And if we ever master the technology to terraform Venus, it would open the door to transforming other hostile worlds as well. So, can we make hell a paradise? The science isn't there yet, but Venus reminds us of the potential for human ingenuity. If we can dream it, maybe one day we can build it. Cryosleep pods. Real science or sci-fi dream? Cryosleep pods have been a staple of science fiction for decades, from Alien to Interstellar. The idea is simple. Put humans into a state of suspended animation for long-duration space travel. But is cryosleep real science or just a sci-fi dream? The concept of cryosleep is based on the idea of slowing down the body's metabolism to the point where you're essentially in hibernation. Animals like bears and squirrels do this naturally, lowering their body temperature and heart rate to conserve energy during winter. If we could replicate this process in humans, it could solve one of the biggest challenges of interstellar travel: the sheer amount of time it takes. NASA is already exploring this idea. One approach involves therapeutic hypothermia, a medical technique used to lower a patient's body temperature to slow their metabolism. It's currently used in hospitals for certain surgeries or after cardiac arrest. Theoretically, this could be adapted for space travel, putting astronauts into a state of hibernation for months or even years. But there are major hurdles. For starters, we don't fully understand how hibernation works in animals, let alone how to safely induce it in humans. There's also the issue of maintaining muscle mass and bone density during long periods of inactivity. Astronauts already experience these problems in space, even with regular exercise. Imagine being immobile for years. Another challenge is technology. Cryosleep pods would need to monitor and regulate every aspect of the human body: temperature, oxygen levels, hydration, and more. They'd also need to wake people up safely without causing permanent damage. We're talking about machines that don't exist yet. And then there's the question of how long cryosleep could actually last. Could we hibernate someone for decades or even centuries? Theoretically, yes. But we'd need to prevent long-term damage to tissues and organs. Freezing a body outright isn't an option, as ice crystals would destroy cells. Scientists are exploring cryoprotectants, chemicals that could prevent ice formation, but these are still in the experimental phase. Despite these challenges, the potential benefits of cryosleep are huge. It could drastically reduce the amount of food, water, and oxygen needed for long-term missions. It could also help astronauts cope with the psychological strain of spending years in space. So, is cryosleep real science or just a sci-fi dream? Right now, it's somewhere in between. The groundwork is being laid, but we're still a long way from boarding a ship and hibernating our way to Alpha Centauri. For now, cryosleep remains a tantalizing vision of the future, a reminder of how far we still have to go. The 100-year Starship project, humanity's first interstellar mission. Interstellar travel sounds like the ultimate dream, leaving our solar system and exploring planets around distant stars. But we're not just dreaming anymore. The 100-year Starship project is a real initiative dedicated to making interstellar travel possible within the next century. So, what exactly is this project? And can it succeed? The 100-year Starship was founded in 2011 with funding from DARPA, the US military's advanced research arm, and NASA. Its mission isn't to build a Starship itself, but to create the framework for future generations to develop the technology, knowledge, and infrastructure necessary for interstellar travel. Think of it as planting the seeds for humanity's ultimate voyage. But let's be real, the challenges are monumental. The nearest star system, Alpha Centauri, is about 4.37 light-years away. Even if we could travel at 10% of the speed of light, a speed far beyond anything we've achieved, it would take over 40 years to get there. And that's assuming we have a spacecraft capable of sustaining a crew for that long. One of the biggest hurdles is propulsion. Conventional rocket engines won't cut it for interstellar travel. They're just too slow. Instead, scientists are exploring more advanced options like nuclear fusion engines, which could theoretically provide enough energy for high-speed travel. Another concept is a solar sail, which uses light from the sun or lasers to push a spacecraft forward. The Breakthrough Starshot initiative is already testing small prototypes of this idea. Then there's the issue of sustainability. A journey lasting decades or centuries would require a spacecraft capable of supporting human life for the long haul. This means creating a closed-loop system where resources like water, oxygen, and food are continuously recycled. It's not just a technological challenge, it's a social one too. How do you keep a crew sane and functioning during a multi-generational mission? This brings us to the concept of generation ships. These massive spacecraft would carry entire communities of people who live, work, and eventually pass the mission on to their descendants. It's a fascinating idea, but it raises ethical questions. Is it fair to commit future generations to a journey they didn't choose? The 100-year Starship project isn't just about building technology, it's about asking these tough questions. It's bringing together scientists, engineers, philosophers, and even artists to imagine what interstellar travel could look like. The goal is to inspire humanity to think big and take the first steps toward becoming an interstellar species. So, will we build a starship in 100 years? It's impossible to say, but the project reminds us that every great journey begins with a single step. And who knows, maybe one day a ship carrying our descendants will set sail for the stars, fulfilling the dream that started it all. Space elevators. Are they closer than you think? Getting into space is expensive, dangerous, and resource-intensive. But what if we didn't need rockets to leave Earth? What if we could take an elevator to orbit? It sounds like science fiction, But the idea of a space elevator has been around for over a century, and we might be closer to building one than you think. The concept is simple. A massive cable stretches from Earth's surface to a point in space, anchored to a platform in geostationary orbit. Elevators, or climbers, would travel up and down this cable, carrying cargo and people into space. No rockets, no explosions, just a smooth ride to the stars. The potential benefits are huge. Space elevators could reduce the cost of sending materials into orbit by up to 95%, making space accessible to more countries, companies, and individuals. They could also enable continuous transportation of goods and supplies, supporting space stations, lunar bases, and beyond. But here's the catch. The materials needed to build a space elevator don't exist yet. The cable would have to be incredibly strong and lightweight, far stronger than steel or any other material we currently use. Some scientists believe carbon nanotubes or graphene could be the solution. These materials have the theoretical strength to support a space elevator, but producing them at the necessary scale is still a long way off. Then there's the question of where to build it. A space elevator would need to be located near the equator to take advantage of Earth's rotational speed. Possible sites include international waters, where no single country would control it. But the challenges don't stop there. The cable would need to withstand extreme weather, including hurricanes and lightning strikes. It would also need to dodge space debris and micrometeoroids, which could slice through it like a knife through butter. Despite these obstacles, there's real progress being made. Japan's Obayashi Corporation has announced plans to build a space elevator by 2050. Meanwhile, researchers are developing prototypes of climbers and studying the feasibility of tether materials. So, are space elevators closer than we think? Maybe. They're still decades away at best, but the idea isn't as far-fetched as it once seemed. And if we ever pull it off, it could revolutionize the way we explore and inhabit space. Will space become militarized? The truth about space wars. For most of human history, space exploration has been a symbol of peace and cooperation. But as more nations and companies enter the space race, there's a growing concern: could space become the next battlefield? Are we headed for a future of space wars? The militarization of space isn't new. During the Cold War, the US and Soviet Union both developed anti-satellite weapons and other space-based technologies for defense. But they also signed treaties to prevent the deployment of weapons of mass destruction in orbit. The 1967 Outer Space Treaty, for example, prohibits the militarization of the Moon and other celestial bodies. Fast forward to today, and the landscape is changing. Nations like the US, China, and Russia are investing heavily in space-based military technologies. Satellites are now critical for communication, navigation, and surveillance, and that makes them valuable targets in a conflict. In 2007, China tested an anti-satellite missile by destroying one of its own satellites, creating thousands of pieces of dangerous debris. Other countries, including the US and India, have conducted similar tests. These demonstrations show that the ability to disable satellites is no longer hypothetical. It's real. Then there's the rise of private companies like SpaceX and Blue Origin. While their focus is on commercial ventures, their technologies could have military applications. SpaceX's Starlink satellites, for example, have been used to provide internet to Ukraine during its conflict with Russia. This dual-use nature of space technology blurs the line between civilian and military purposes. Some experts worry that the establishment of organizations like the US Space Force could escalate tensions. Critics argue that it signals an arms race in space, with nations rushing to secure strategic advantages. But there's also hope for diplomacy. International agreements, like the Artemis Accords, aim to promote peaceful exploration and prevent conflicts in space. The challenge will be getting all major spacefaring nations to agree and ensuring that the rules are enforceable. So, will space become militarized? The truth is, it already has to some extent. The question is whether we can prevent a full-scale arms race or even outright warfare in orbit. Because if we can't, the final frontier might become the next battlefield. Artificial gravity. Can we spin our way through space? Gravity is something we take for granted on Earth. It keeps our feet on the ground, our bones strong, and our bodies functioning properly. But in space, it's a whole different story. Without gravity, astronauts face serious health risks like muscle atrophy, bone loss, and even vision problems. So, is artificial gravity the answer? And can we actually spin our way through space? The concept of artificial gravity is straightforward. You create it by generating a force that mimics gravity. One of the most promising methods involves centrifugal force. If you've ever been on a spinning carnival ride that pins you to the wall, you've experienced a form of artificial gravity. In space, a rotating spacecraft could create a similar effect, pushing people downward toward the walls of the ship. But how fast would you need to spin? The faster the rotation, the stronger the artificial gravity. Scientists estimate that a structure about 100 meters in diameter would need to rotate around twice per minute to create Earth-like gravity. The problem is, spinning too quickly could make people dizzy or even sick due to something called the Coriolis effect, which can mess with your inner ear. That's why larger structures are better for creating artificial gravity. They can spin more slowly while still generating the same effect. Think of massive rotating space stations, like the ones in movies like 2001, A Space Odyssey. These designs aren't just sci-fi fantasies, they're based on real physics. NASA and other space agencies have studied artificial gravity for decades, but it hasn't been implemented yet. Why? Cost and complexity. Building a rotating spacecraft or space station would require enormous resources and engineering breakthroughs. For now, astronauts on the International Space Station rely on daily exercise to counteract the effects of microgravity, but it's not a perfect solution. Artificial gravity wouldn't just benefit astronauts on long missions. It could also make space travel more comfortable. Imagine being able to walk around a spacecraft, eat meals at a table, and sleep in a normal bed, instead of floating in microgravity. It's not just about health. It's about creating a livable environment for extended stays in space. There's even talk of using artificial gravity for interstellar travel. Generation ships, which would carry entire communities on journeys lasting centuries, would likely need some form of artificial gravity to maintain the health of their passengers. So, can we spin our way through space? The physics is solid, but the engineering challenges are immense. Still, as humanity reaches farther into the cosmos, artificial gravity might not just be an option, it could become a necessity. Generation ships. How to survive on a 1,000-year journey. If we're ever going to explore planets outside our solar system, we'll need to face a hard truth. Interstellar travel is slow. Even with the most advanced propulsion systems, journeys to the nearest stars could take hundreds or even thousands of years. That's where generation ships come in. But how do you design a spacecraft capable of sustaining life for centuries? A generation ship is exactly what it sounds like. A massive spacecraft where multiple generations of humans live, grow old, and pass the mission on to their descendants. It's less about going there and more about creating a self-sustaining society in space. The biggest challenge is creating a closed-loop ecosystem. On Earth, we rely on a complex web of plants, animals, and microbes to recycle air, water, and nutrients. A generation ship would need to replicate this on a much smaller scale. This means growing crops, recycling waste, and maintaining a stable atmosphere, all in a sealed environment. It's not just about surviving, it's about thriving for centuries. Then there's the issue of space. A generation ship would need to be enormous, with living quarters, farms, recreational areas, and storage for supplies. But size comes with a cost. Building and launching something that big would be one of the most ambitious engineering feats in history. And what about the people? Life on a generation ship would be unlike anything we've ever experienced. The crew wouldn't just be astronauts, they'd be families, teachers, doctors, and engineers. They'd need to build a functioning society, complete with its own culture, laws, and governance. Psychology would also play a huge role. How do you keep people motivated on a mission where they'll never see the destination? Imagine being born knowing that your life's work is to help a future generation reach a planet you'll never set foot on. It's a profound challenge, not just technically, but emotionally. And then there's the question of sustainability. What happens if something goes wrong? A crop failure, a system's malfunction, or even a social conflict could threaten the entire mission. Redundancy and adaptability would be key. Every system would need a backup, and every crew member would need to wear multiple hats. Despite these challenges, the idea of generation ships isn't just theoretical. Scientists and engineers are already studying closed-loop systems, like the BIOS-3 experiment in Russia and NASA's research on bioregenerative life support systems. These projects are laying the groundwork for the self-sustaining habitats we'll need for long-term space travel. Generation ships are more than just vessels, they're microcosms of humanity. If we can learn to live sustainably on a spacecraft, it might even teach us how to live more sustainably here on Earth. So can we survive a 1,000-year journey to the stars? It's one of the biggest questions humanity has ever faced. But if we succeed, it would be the ultimate testament to our creativity, resilience, and desire to explore. Alien contact. Will space travel lead us to our galactic neighbors? One of the biggest questions in human history is also one of the simplest. Are we alone in the universe? Space travel brings us closer to answering that question, and with every step we take beyond our solar system, the odds of encountering alien life increase. But what would happen if we actually made contact? First, let's consider the sheer numbers. The observable universe contains an estimated 2 trillion galaxies, each with billions of stars and even more planets. Scientists estimate that there could be as many as 300 million potentially habitable planets in the Milky Way alone. With numbers like that, it's hard to believe Earth is the only place where life exists. But finding alien life isn't easy. Space is mind-bogglingly vast, and even the closest stars are light years away. That's why scientists are focusing on finding biosignatures, indicators of life like oxygen, methane, or water vapor, in the atmospheres of exoplanets. Instruments like the James Webb Space Telescope are already hunting for these clues. Then there's the possibility of intelligent life. Organizations like SETI, the Search for Extraterrestrial Intelligence, have been scanning the skies for decades, listening for signals that might indicate advanced civilizations. So far, we've heard nothing definitive, but that doesn't mean no one's out there. It might just mean we're looking or listening in the wrong way. But let's get hypothetical. What if we do find intelligent aliens? How would we communicate with them? For starters, we'd need to find a common language. Math and physics are often considered universal, but even those could be interpreted differently by beings with a completely different way of thinking. And then there's the question of what kind of aliens we might meet. Would they be peaceful explorers like us, or something more dangerous? Some scientists, like Stephen Hawking, have warned against actively reaching out to extraterrestrial civilizations. He compared it to when Europeans encountered Native Americans. Historically, the more advanced civilization didn't always have the best intentions. On the flip side, contact with aliens could bring incredible opportunities. Imagine the knowledge we could gain from a species that's been traveling the stars for millennia. Advanced technologies, cures for diseases, solutions to problems we can't even imagine. All of it could be on the table. Of course, the biggest hurdle is time. Even if we receive a signal from an alien civilization, it might take decades or centuries for us to respond, depending on how far away they are. And that's assuming we understand the message in the first place. So, will space travel lead us to our galactic neighbors? It's impossible to say for sure. But as our telescopes grow more powerful and our spacecraft travel farther, the possibility becomes more real. And if we do make contact, it won't just change science. it will change humanity forever. The future of space exploration, AI pilots, and human hybrids. The future of space exploration isn't just about rockets and spacecraft. It's about the people and technologies that will make it all possible. As missions grow longer and more complex, we'll need more than just astronauts. Enter AI pilots and human hybrids, two revolutionary ideas that could redefine how we explore the cosmos. Let's start with AI pilots. Artificial intelligence is already playing a huge role in space exploration. NASA's Mars rovers, like Curiosity and Perseverance, use AI to navigate the Martian surface and make decisions in real time. But future I could go far beyond that. Imagine a fully autonomous spacecraft piloted by an advanced AI. It wouldn't need food, water, or sleep, and it could make split-second decisions without waiting for instructions from Earth. This would be especially useful for deep space missions, where communication delays can stretch for minutes, or even hours. AI pilots could also assist human crews by monitoring spacecraft systems, solving problems, and even providing emotional support. But what about human hybrids? As we push the boundaries of space exploration, it's becoming clear that our bodies aren't well suited for the harsh environments of space. Radiation, microgravity, and long-term isolation all take a toll. Some scientists believe the answer might lie in bioengineering, altering our DNA to make us better adapted to life in space. For example, we could edit genes to make humans more resistant to radiation or less prone to muscle and bone loss in microgravity. Scientists have already identified genes in certain animals, like tardigrades, that give them incredible resilience to extreme conditions. In theory, these genes could be introduced into humans to enhance our ability to survive in space. But bioengineering isn't just about making us tougher. It could also be about making us smarter or more adaptable. Enhanced cognitive abilities could help astronauts solve complex problems on the fly, while modifications to our circadian rhythms could make it easier to adjust to the 24.6-hour day on Mars. Of course, both AI pilots and human hybrids raise ethical questions. Should we alter our biology for the sake of exploration? And how do we ensure that AI systems remain tools and not overlords? These are debates we'll need to have as the technology advances. The future of space exploration is a partnership between humanity and technology. Whether it's through AI, bioengineering, or other innovations we haven't even imagined yet, one thing is clear: the next chapter of our journey to the stars will look very different from the first. Could Dyson Spheres turn us into a galactic civilization? We use energy for everything: our homes, industries, and technology. But even our most advanced power plants are nothing compared to the energy output of a single star. What if we could capture the entire energy of the sun? That's exactly what a Dyson Sphere would do. A Dyson Sphere is a hypothetical megastructure first proposed by physicist Freeman Dyson in 1960. It describes a system of satellites, mirrors, or panels that completely surround a star, capturing and using all of its energy. If we could build one, it would instantly transform us into a Type 2 civilization on the Kardashev scale, a classification system that measures how much energy a civilization can harness. To put this in perspective, Earth receives about 1/1000th of the sun's total energy output. A Dyson Sphere could capture 100% of that energy, giving us trillions of times more power than we use today. The science behind Dyson Spheres. At first glance, the concept makes sense. The sun is constantly blasting energy in all directions, and most of it goes to waste in space. Why not put up giant collectors to harvest that energy? But building a solid shell around a star, like the classic sci-fi depiction of a Dyson Sphere, isn't possible. The gravitational forces alone would tear it apart. Instead, most scientists propose a Dyson swarm, a vast network of orbiting solar panels or structures that collect the sun's energy and transmit it back to Earth. This approach is much more feasible because it doesn't require a single massive structure. However, even a Dyson swarm would require insane amounts of material. To build enough solar collectors, we'd have to dismantle entire planets, possibly mining Mercury for its rocky materials and using asteroid metals to construct the framework. What would a Dyson sphere mean for humanity? If we ever built one, the impact would be astronomical. A Dyson sphere would give us nearly limitless energy, allowing us to power entire planets with ease, terraform Mars, Venus, and beyond, run supercomputers at mind-blowing speeds, develop interstellar ships with near-infinite power, create artificial gravity and climate control systems. It would be humanity's ultimate power source. But could aliens have already done this? Some astronomers are searching for Dyson spheres built by extraterrestrials. If an advanced civilization constructed one, we might be able to detect it by looking for stars that are mysteriously dim, as the megastructure would block some of their light. In 2015, a star called KIC 8462852, nicknamed Tabby's star, showed strange dimming patterns that led some scientists to wonder if an alien megastructure was orbiting it. While natural explanations like dust clouds are more likely, the hunt for Dyson spheres in space is far from over. Could we actually build one? The biggest challenges would be material requirements. We'd need to dismantle entire planets or develop self-replicating machines that could build the structure for us. Orbital mechanics. Keeping a swarm of solar panels in place around a star without them colliding would require next-level physics. Energy transmission. Once we collect the sun's energy, we'd need to beam it to Earth via microwave transmission or laser arrays without frying our own planet. So even though we're nowhere near building a Dyson sphere today, some researchers believe we could start working toward one within the next 500 to 1,000 years. What would it mean for our future? If humanity ever reaches the Dyson sphere stage, we wouldn't just be a spacefaring species, we'd be a galactic powerhouse. We'd have the energy to expand beyond our solar system, create artificial planets, and possibly simulate entire universes with our computing power. Would you want to live in a Dyson sphere-powered future? Or does controlling an entire star seem too ambitious? Either way, this is one of the most mind-blowing concepts in science, and one that could shape the fate of intelligent civilizations. The simulation hypothesis. Are we living in a cosmic video game? What if everything you see, hear, and experience, your entire life, was just an incredibly advanced simulation? This is the simulation hypothesis, and it suggests that our universe might not be real in the way we think it is. Instead, we could be living inside a hyper-advanced computer program created by a civilization far more technologically advanced than our own. This isn't just some sci-fi concept, it's an idea taken seriously by scientists and philosophers, including Elon Musk, Nick Bostrom, and many others. And if it's true, it would completely change everything we think we know about reality. The core idea, why the simulation hypothesis makes sense. The argument goes like this. 1. Technology is advancing at an exponential rate. Video game graphics, AI, and virtual reality have improved dramatically over just the past few decades. Imagine where they'll be in 1,000 years, or 10,000. At some point, simulations will become indistinguishable from reality. 2. If civilizations can create ultra-realistic simulations, they will. We already run computer simulations of weather patterns, economic systems, and even the origins of the universe. It's not crazy to think that a super-advanced civilization would create simulations of their past, meaning a simulation of us. 3. If even one civilization creates perfect simulations, then there could be billions of them. If you assume that countless simulated universes could be created, then statistically speaking, it's far more likely that we're inside one of those simulations rather than in the real universe. This is what philosopher Nick Bostrom proposed in his famous simulation argument, that given enough time, advanced civilizations would inevitably start simulating their ancestors, and we could very well be inside one of those simulations right now. Could we detect that we're in a simulation? If we really are in a simulation, could we find evidence of it? Some researchers think so. Here are some theories. Glitches in physics. If our universe is a simulation, it might have occasional glitches or inconsistencies, like weird quantum mechanics behaviors. The fact that particles can exist in multiple states at once, quantum superposition, is something that doesn't quite make sense in classical physics. Could it be a rendering trick in a cosmic computer? The speed of light is a processing limit. Some scientists have speculated that the speed of light could be the maximum processing speed of the simulation, similar to how video games have frame rate limits. Pixelation of the universe. If the universe is simulated, it might have a smallest possible unit, just like pixels on a screen. Some physicists are searching for evidence that space itself is quantized, meaning there's a smallest possible resolution to reality. Mysterious constants in physics. The laws of physics seem oddly fine-tuned for life. If any of the fundamental constants of the universe, like gravity, electromagnetism, or nuclear forces, were slightly different, life wouldn't exist. Could this be evidence that someone programmed our universe this way? What would it mean if we're in a simulation? If we are inside a simulation, it raises huge philosophical and ethical questions. Who built it? Are we part of an advanced alien experiment? A historical reconstruction? A form of entertainment for a post-human society? What happens if they shut it off? If the simulation ends, do we just disappear? Do we have free will? If we're just code in a cosmic program, do our choices actually matter? Some people even speculate that certain religions may have predicted this. After all, many belief systems describe the world as an illusion, controlled by a higher power. Maybe they were onto something all along. So, are we in a simulation? Right now, there's no definitive proof, but many of the smartest minds on the planet take this idea seriously. In fact, Elon Musk once said that there's a 1,000,000,000 to 1 chance we are not in a simulation, meaning he thinks it's almost certain we are. But here's the ultimate question. If we are in a simulation, does it even matter? If everything we experience feels real, if we can think, love, create, and explore, does it actually change anything? Or maybe we're not meant to find out. Maybe, if we get too close to the truth, whoever is running the simulation might just pull the plug. What if we could move the entire solar system? It sounds like something out of science fiction, moving not just a spaceship, not just a planet, but our entire solar system. But some scientists have actually proposed ways we could do it. And the reason? Pure survival. The universe is a dangerous place. In about 5 billion years, the sun will expand into a red giant, swallowing Mercury, Venus, and possibly Earth before collapsing into a white dwarf. That's just the long-term problem. More immediate threats include supernova explosions, gamma-ray bursts, rogue planets, and even the slow gravitational drift of our solar system through the Milky Way. If humanity lasts long enough, we might have to face a terrifying truth. We either move the solar system or die with it. One of the most promising ideas is called a Shkadov thruster, a theoretical megastructure that could turn the sun into a kind of cosmic engine. The idea is surprisingly simple. Build a giant mirror, millions of miles across, that reflects the sun's light in one direction. This would create an unbalanced force, pushing the sun ever so slightly. Over thousands or even millions of years, this slow but steady push could actually move the entire solar system. The main challenge is scale. A Shkadov thruster would have to be unimaginably large, possibly built from materials harvested from Mercury or even entire asteroids. But the real issue isn't just building it, it's waiting for it to work. Moving a star, even with an enormous thruster, would take millions of years. Another, more extreme idea is gravitational steering. If we could find a massive asteroid or a captured dwarf planet, we could use its gravity to slowly tug the sun in a specific direction. By carefully controlling flybys over millions of years, We could theoretically guide our solar system like a ship through the galaxy. There's also the idea of controlled stellar explosions, essentially using massive solar flares or carefully timed energy bursts to generate thrust. The challenge with this method is that it could destabilize the sun itself, making it just as dangerous as the threats we're trying to escape. Even if we could move the solar system, there's still the problem of choosing where to go. The Milky Way is full of dangers, from black holes to interstellar radiation clouds. Would we head toward another promising star system? Or drift endlessly, using our newfound mobility to avoid cosmic threats as they appear? The idea of moving an entire solar system might sound absurd today, but then again, so did flying to the moon just a century ago. The real question isn't whether it's possible, it's whether we'll ever be desperate enough to try. The Great Filter. Why haven't we met aliens? The universe is vast, so vast that it's hard to comprehend. There are at least 200 billion stars in our galaxy alone, and nearly every one of them likely has planets. Some scientists estimate there could be 300 million Earth-like planets in the Milky Way. With numbers like that, you'd think intelligent life would be everywhere, right? So why haven't we met aliens yet? This question is known as the Fermi paradox, and one possible answer is chilling: Great Filter. The Great Filter is the idea that there's something preventing life from reaching the level of an interstellar civilization. Somewhere along the way, civilizations either fail to get started or they wipe themselves out. It's a filter that weeds out life before it can expand across the galaxy. And the big question is, have we already passed the filter, or is it still ahead of us? To understand the Great Filter, let's break down the steps required for intelligent life to evolve. First, you need a habitable planet with the right conditions for life to form. Next, simple organisms need to evolve into complex ones. Eventually, those organisms must develop intelligence, create technology, and avoid self-destruction long enough to spread to other planets. Each of these steps is a potential bottleneck, a moment where things could go horribly wrong. One possibility is that the filter is behind us, meaning intelligent life is incredibly rare. Maybe it's extraordinarily difficult for life to evolve in the first place. After all, Earth was lucky enough to have liquid water, a magnetic field, plate tectonics, and just the right distance from the sun. If even one of these factors had been slightly off, life might never have arisen here. Another theory is that the transition from simple life to complex life is the hardest step. For billions of years, Earth was dominated by microbes before the sudden explosion of complex organisms during the Cambrian period. This transition is incredibly rare. We might already be one of the lucky few planets to make it this far. But the scarier possibility is that the Great Filter is ahead of us. This would mean that many civilizations do reach the stage of intelligence and technology, but they fail to survive long enough to explore the galaxy. Perhaps they destroy themselves through nuclear war, environmental collapse, or runaway artificial intelligence. Or maybe the universe itself is hostile to life, with gamma-ray bursts, supernovae, or rogue black holes wiping out civilizations before they can expand. There's also the idea that advanced civilizations might simply lose interest in space exploration. Once they've achieved post-scarcity societies or perfected virtual reality, they might turn inward, abandoning the idea of colonizing other worlds. The discovery of alien life could give us a clue about the Great Filter. If we find simple life on Mars or Europa, it would suggest that life itself is common, but complex life might still be rare. On the other hand, if we find evidence of a dead civilization, a planet that was once thriving but is now barren, it could mean that self-destruction is the filter we all must face. The Great Filter forces us to confront our own future. If it's ahead of us, we must work to avoid the pitfalls that could doom our civilization. If it's behind us, it means we might be one of the only intelligent species in the galaxy. That's both thrilling and terrifying. Either way, the The Great Filter is a sobering reminder of how fragile life is and how precious our place in the universe might be. Could we create a second Earth? Terraforming an entire planet. What if we didn't need to search for another Earth-like planet? What if we could simply build one ourselves? The idea of creating a second Earth, either by terraforming an existing planet or constructing one from scratch, is one of the most ambitious concepts in science. But could humanity ever pull it off? Terraforming is the process of transforming a planet into an environment that's habitable for humans. Mars is the most obvious candidate. It's close, it has frozen water, and its day is similar in length to Earth's. But Mars is far from perfect. The atmosphere is thin and mostly carbon dioxide. Temperatures are freezing, and there's no magnetic field to protect against solar radiation. To terraform Mars, we'd need to radically change its environment. One idea is to release greenhouse gases, like carbon dioxide, into the atmosphere, warming the planet and creating a thicker atmosphere. Another concept involves placing giant mirrors in orbit to reflect sunlight onto the surface, melting the polar ice caps and releasing water vapor. Some scientists have even suggested crashing comets or asteroids into Mars to deliver water and heat. The challenges, however, are enormous. Terraforming Mars could take thousands of years, and even then, it might never be as comfortable as Earth. That's why some researchers have proposed an even crazier idea: building an artificial planet. Constructing a second Earth from scratch would require dismantling asteroids, moons, or even planets to harvest materials. Using advanced robotics and self-replicating machines, we could assemble these materials into a giant shell with an artificial core, atmosphere, and climate systems. We'd also need to create artificial gravity, possibly by spinning the planet or using futuristic gravity control technologies. This kind of project is pure science fiction for now, but it's not entirely impossible. The same technologies we'd need to terraform Mars, like atmosphere control and climate engineering, could someday be scaled up to create entirely new worlds. The real question is whether we'd want to. Building or terraforming planets isn't just a technical challenge, it's an ethical one. Should we transform another world to suit our needs, potentially destroying any native ecosystems that might exist? Or should we learn to live more sustainably on Earth, preserving the planet we already have? Creating a second Earth might sound like an escape plan, but it could also be an incredible opportunity. If we ever master the ability to build habitable worlds, it would unlock a new era of cosmic engineering, giving humanity the tools to thrive anywhere in the universe. The question isn't just, can we do it? It's, will we need to? Time travel and the paradoxes that could break reality. Time travel has been one of humanity's greatest fascinations for centuries. The idea of stepping into a machine, spinning some dials, and traveling to the distant past or far-off future feels like something ripped straight from science fiction. But here's the wild thing: time travel might not be entirely impossible. The question is, if we could do it, would it completely break the universe? Time travel has its roots in Albert Einstein's theory of relativity, which showed that time isn't constant. Instead, it's flexible. It stretches and bends based on speed and gravity. If you travel at close to the speed of light, time slows down for you compared to someone standing still. This is called time dilation, and it's not just theoretical. Astronauts on the International Space Station experience tiny amounts of time dilation due to their speed and distance from Earth's gravity. But what about traveling into the past? This is where things get tricky and weird. One theoretical way to travel through time is by using wormholes, which are shortcuts through space-time. Imagine folding a piece of paper in half so that two distant points touch. That's essentially how a wormhole works. In theory, if one end of the wormhole was accelerated to near light speeds and then brought back, it would be in a different point in time than the other end. Another possibility is using massive gravitational forces to manipulate time. Black holes, for example, warp space-time so much that time moves more slowly near their event horizons. If you were to orbit a black hole for a year and then return to Earth, decades could have passed here while only a year passed for you. But as fun as it sounds, time travel comes with paradoxes. Mind-bending logical problems that could make it impossible, or at least incredibly dangerous. The most famous is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you'd never be born. So how could you have traveled back in time in the first place? Another is the bootstrap paradox, where information or objects are sent back in time, creating a loop with no clear origin. Imagine traveling to the past and giving Shakespeare a copy of Hamlet. He publishes it, and centuries later you bring it back to him again. Who actually wrote it? Some physicists think these paradoxes might resolve themselves through quantum mechanics. For example, in a concept called the many worlds interpretation, every time you travel to the past, you create a new branch of reality. If you accidentally prevent your own birth, it doesn't erase you. It just creates an alternate timeline where you don't exist. But let's say time travel is possible, paradoxes and all. How would it even work? Would we invent machines capable of manipulating space-time? Would we rely on natural phenomena like wormholes or cosmic strings? And what would the rules be? Could we interact with the past, or would we be mere observers, like ghosts? Some scientists suggest that time travel could already be happening, only for particles, not people. In experiments, researchers have observed particles that seem to borrow energy from their future selves to appear in the present. It's called quantum tunneling, and while it's not the same as building a time machine, it hints that space-time may be far stranger than we understand. The biggest question is, should we even attempt time travel? What happens if we accidentally break history? Or worse, what if someone with bad intentions weaponizes time travel? Entire civilizations could be erased with a single change to the past. Time travel remains one of the most tantalizing possibilities in physics. If we ever figure it out, it won't just redefine science, it'll redefine our place in the universe. But until then, it's one of humanity's greatest mysteries, waiting to be unlocked. Space whales and other theories about extraterrestrial life forms. Whenever we imagine aliens, we tend to picture humanoid creatures. 2 arms, 2 legs, maybe a few extra eyes or tentacles for good measure. But what if intelligent life in the universe is nothing like us? What if it's so alien that we might not even recognize it when we see it? Take a moment to consider just how weird life on Earth can be. Deep in our oceans, you'll find creatures like giant squids with eyes the size of dinner plates, or bioluminescent fish that glow in complete darkness. These aren't aliens, they're Earthlings. Now imagine the kinds of creatures that could evolve under completely different conditions on another planet. One theory suggests that intelligent alien life could exist on ocean worlds, planets covered entirely by water. In these environments, intelligent beings might resemble giant whale-like creatures. Instead of building technology, they could communicate through complex songs or electromagnetic pulses. Entire civilizations might exist underwater, hidden beneath thick layers of ice, making them nearly impossible for us to detect. Then there's the idea of silicon-based life forms. Here on Earth, all known life is carbon-based. Silicon shares many of the same chemical properties. On planets with extremely high temperatures or harsh environments, silicon might take the place of carbon, creating creatures that are rock-like, crystalline, or even metallic. Some scientists believe life could be even more exotic. What if intelligent beings weren't made of matter at all? In regions of space with intense electromagnetic activity, it's possible to imagine creatures made entirely of energy, sentient, glowing clouds drifting through the cosmos. Such beings might live for millions of years and think in ways we couldn't begin to comprehend. There's also the possibility of machine life, artificial intelligences that have outlived their creators. If an alien civilization built machines capable of self-replication, those machines could spread throughout the galaxy long after the original species had gone extinct. In fact, Some scientists suggest we should be searching for evidence of alien technology rather than biological organisms. One of the biggest challenges in searching for alien life is that we're limited by our own perspective. We expect life to look a certain way because we're used to the rules of Earth. But the universe is unimaginably vast and diverse. Life out there could be microscopic or planet-sized, organic or mechanical, peaceful or predatory. It might even be so alien we wouldn't recognize it as life at all. The more we study the universe, the more it challenges our assumptions. If intelligent aliens do exist, they could be more bizarre, beautiful, and terrifying than anything we've ever imagined. And that's what makes the search for them so exciting. The strangest exoplanets ever discovered. When astronomers began discovering planets outside our solar system, or exoplanets, in the 1990s, they expected to find worlds similar to the ones in our own neighborhood. Rocky planets like Earth, gas giants like Jupiter, and maybe a few icy worlds like Neptune. But instead, they found planets that defied everything we thought we knew about how planets form and behave. Some of these exoplanets are so strange they feel like they belong in a sci-fi movie. Let's dive into some of the weirdest and most mind-bending exoplanets ever discovered. One of the most famous is HD 189733b, a planet about 64 light-years away. At first glance, it looks like a gas giant similar to Jupiter, but the weather on this planet is beyond extreme. Winds whip through its atmosphere at speeds of over 5,400 miles per hour. That's 7 times the speed of sound. And if that wasn't bad enough, it rains molten glass. The planet's atmosphere is filled with silicate particles that condense in the scorching heat, creating glass shards that rain sideways thanks to those insane winds. Then there's 55 Cancri, a rocky planet twice the size of Earth and located about 40 light-years away. Scientists believe this planet's surface might be made of diamonds. Yes, an entire planet of sparkling, valuable gemstones. This is because the planet is rich in carbon, experiences immense pressure and heat, which could transform its carbon into diamonds. It sounds like the ultimate treasure trove. With surface temperatures reaching nearly 4,000 degrees Fahrenheit, it's unlikely we'll be mining diamonds there anytime soon. Another oddball is WASP-12b, a gas giant that's slowly being eaten alive by its star. This planet orbits so close to its host star that it completes a full orbit in just over a single Earth day. The intense gravity from the star is pulling material off the planet, creating a comet-like tail of gas and plasma. Scientists estimate that WASP-12b could completely disintegrate in just a few million years, which is practically the blink of an eye on cosmic timescales. And then there's Kepler-16b, a planet straight out of Star Wars. This world orbits not one but 2 stars, making it a real-life Tatooine. From the surface, you'd see 2 suns in the sky, one slightly smaller and dimmer than the other. While it's unlikely that Kepler-16b is habitable, it's a cold gas giant. The fact that planets can orbit binary star systems opens up a whole new realm of possibilities for finding Earth-like worlds. But some of the strangest exoplanets aren't the hottest or brightest, they're the loneliest. Rogue planets, like the ones we discussed earlier, are exoplanets that don't orbit a star at all. These planets drift through space in eternal darkness, some with faint internal heat that keeps their subsurface oceans liquid. One such planet, PSOJ 318.5-22, is a gas giant about 80 light-years away. It's completely untethered to any star, glowing faintly with the leftover heat from its formation. And then there's Tries-2b, also known as the darkest planet ever discovered. This gas giant reflects less than 1% of the light that hits it, making it blacker than coal. Scientists aren't entirely sure why it's so dark, but its atmosphere may contain chemicals like vaporized sodium or potassium that absorb light rather than reflecting it. Finally, there's TOI 849b, a planet that may be the exposed core of a failed gas giant. Imagine if Jupiter's atmosphere were stripped away, leaving only its dense, rocky core behind. That's what TOI 849b appears to be. This naked core is providing scientists with a rare glimpse into the interior of gas giants, something we'd never be able to study in our own solar system. These strange exoplanets show just how diverse and unpredictable the universe can be. They challenge our assumptions about how planets form and remind us that the cosmos is full of surprises. Who knows what other bizarre worlds are waiting to be discovered? Perhaps there are planets even stranger than these, worlds with entirely new types of materials, atmospheres, or life forms. The more we explore, the more we realize just how much we don't know. But one thing's for sure, the universe is far stranger and far more amazing than we could ever imagine. Could we create a second Earth? Terraforming an entire planet. What if humanity could stop searching for an Earth-like planet in the galaxy and simply build one from scratch? The idea of creating a second Earth is one of the most ambitious concepts in all of science, involving cutting-edge technology, cosmic engineering, and a bit of imagination. But is it possible? And if so, what would it take to construct or terraform a world, to make it just like home? One approach to creating a second Earth is terraforming, or transforming an existing planet to be more Earth-like. Mars is the most likely candidate for terraforming, given its proximity to Earth and some of its natural resources. Mars has polar ice caps, underground water, and a day length similar to ours. However, it's far from habitable in its current state. Its atmosphere is thin and composed almost entirely of carbon dioxide, and temperatures rarely rise above freezing. To terraform Mars, we'd need to thicken its atmosphere and warm its surface. One proposed method is to release greenhouse gases like carbon dioxide and methane into the atmosphere. These gases would trap heat much like they do on Earth and slowly warm the planet over time. Another idea is to use giant orbital mirrors to reflect sunlight onto Mars' surface, melting its polar ice caps and releasing water vapor into the atmosphere. This could create rivers, lakes, and even oceans. More ambitious proposals suggest bombarding Mars with comets or asteroids to deliver water, heat, and additional gases. While this sounds like science fiction, it's technically feasible. By redirecting objects in the asteroid belt, we could introduce new resources to Mars and jumpstart the terraforming process. Even with these efforts, terraforming Mars would take hundreds, if not thousands, of years. It's not just about warming the planet, it's about creating a self-sustaining ecosystem. On Earth, plants, animals, and microbes work together to recycle air, water, and nutrients. Replicating that balance on Mars would require introducing plants capable of surviving in the Martian soil, which is toxic due to high levels of perchlorates. We'd also need to engineer microbes that can break down those toxins and make the soil fertile. But Mars isn't the only option. Some scientists have suggested terraforming Venus, Earth's sister planet. Venus is similar in size and composition to Earth, but its surface is an uninhabitable hellscape, with temperatures reaching nearly 900 degrees Fahrenheit and an atmosphere dominated by carbon dioxide and sulfuric acid clouds. To terraform Venus, we'd first need to cool it down. One idea is to deploy giant reflective shields in orbit to block sunlight, lowering the planet's temperature over time. Another proposal involves introducing microbes that could convert carbon dioxide into oxygen, transforming Venus's atmosphere into something more breathable. The problem with Venus is that even if we fix the atmosphere, we'd still need to deal with the crushing atmospheric pressure, which is about 90 times greater than Earth's. That's why some scientists believe we should focus on building floating cities in Venus's atmosphere, where temperatures and pressures are much more Earth-like. These cities could serve as the first step toward eventually terraforming the planet. If terraforming isn't ambitious enough, there's an even wilder idea: building an entirely new planet from scratch. This concept, often called planetary engineering, involves using raw materials from asteroids, moons, and other celestial bodies to construct a custom-made world. For example, we could dismantle Mercury and use its rocky material to form the core of a new Earth. Using advanced robotics and self-replicating machines, we could piece together the planet layer by layer, creating an atmosphere, oceans, and even artificial gravity. Artificial gravity is one of the biggest challenges. Without the natural pull of a massive core, we'd need to use centrifugal force to simulate gravity. This could involve spinning the planet or building it as a series of rotating habitats. And then there's the question of power. A second Earth would need its own energy source, like a mini-star or a network of fusion reactors. The ethical implications of building or terraforming a planet are enormous. If we terraform Mars or Venus, we might destroy any native ecosystems that exist there, even microbial life. Should we reshape a planet to suit our needs, or should we preserve it as it is? These are questions humanity will need to grapple with as we push the boundaries of what's possible. Creating a second Earth isn't just about survival, it's about opportunity. If we master planetary engineering, we could expand humanity's presence across the galaxy, building new worlds wherever we go. The idea might seem impossible today, but then again, so did flying to the moon just a century ago. With the right technology, determination, and creativity, the universe could become our canvas.